Okay, this video is going to walk you through target number 4 of the geometry review. It's going to focus on two things, parallel lines and triangles, and all the relationships of angles and things that happen between them. So for starters, let's go to the lower half of your target packet and fill in the notes that go in down below. When you first of all start talking about parallel lines, you're going to notice some things that are drawn on the picture. Typically, you're going to see these little double arrows or single arrows drawn on the two parallel lines. That indicates that these lines are parallel and will never cross. Also, there's going to be typically a line drawn diagonally through the two lines, which we call a transversal. Then all these words we refer to are about this picture. So for starters, we have alternate interior angles. Alternate interior angles are angles that are on the inside of the parallel lines, which is 3, 4, 5, and 6, but also opposite sides of the transversal. So if I want to list a couple of those, I could say that angle 3 and 6 are alternate interior angles. They're on the inside and alternate sides of the transversal. You could also argue that 4 and 5 are also considered alternate interior angles as well. That's what we have for the first term. The next term you're going to see is alternate exterior angles. Alternate exterior angles are angles that are on the outside of the parallel lines and opposite sides of the transversal. That's referring to angles 1 and 8, and it's also referring to angles 2 and 7. Hopefully that helps give you an idea of what alternate exterior angles look like. Outside the parallel lines and alternate sides of the transversal. Corresponding angles are angles that happen in the same location of the both intersections. You'll notice there's a crossing intersection here and a crossing intersection going on here. The angle in the top left will also match the angle in the top left as well. And this one here, you're going to have then those angles be congruent. So 5 and 1 are considered are corresponding angles. You could also argue that 2 and 6 are corresponding angles as well. I'm not going to write them all down, but there's more. 8 and 4 and 3 and 7. 3 and 7 being the bottom left corner or bottom left angle in each intersection to refer to those as corresponding. Now going back to all three of these, all of these angles are going to be congruent. These are congruent, these are congruent, and these are congruent. The first three words we have means that when I take these pair of angles, they're all going to be the same measure. Next, same side interior. That means they're on the inside of the parallel lines and the same side of the transversal. That's 4 and 6 and 3 and 5. 4 and 6 and then 3 and 5. When they're like this, you'll notice one's acute and one's obtuse, but even more special, these are going to be supplementary angles. So in same side interior is different than the first three we talked about. These are going to add up to 180 degrees. Same side interior. Next, vertical angles. You want to be looking for opposite V's. Do you see how there's a V going on right here? And there's also a V going on right here. When you have opposite V's, those opposite V's are what we call vertical angles, and they're going to be congruent. So examples would be 2 and 3 are vertical angles, and so are angles 1 and 4. Vertical angles are going to be always considered congruent. Things to consider there. Supplementary angles are two angles that add up to 180 degrees. So we've already referred to a couple of them, 6 and 4, 3 and 5, but they can also form a straight angle like 1 and 2. 1 and 2 can be considered supplementary because they also add up to 180 degrees. Or if you go 2 and 4, 2 and 4, and they always equal 180 degrees. Okay? Next, complementary. There are no complementary angles in this picture unless one of the two angles were to add up to 90 degrees. In this case here, it's not happening. But when I have two angles that add up to 90 degrees, we call that complementary. Those are all the key words you need to be aware of when working with parallel lines in the pictures. Now, what's also you're going to find that happens in these pictures is you're going to find sometimes there are isosceles triangles. An isosceles triangle is defined as a triangle with at least two sides congruent. So that kind of means then that this is also considered an isosceles triangle. It's a special kind of isosceles triangle that we call equilateral. But going back to this one over here, in isosceles triangles, when you have two base angles congruent, if you do, then you have to have congruent sides. Or if you have congruent sides that are both congruent, then the base angles have to be congruent. So always keep that in mind when filling in pictures, and that these are always congruent. Then you know this one here has to top it off at 180 degrees, which we'll talk in just a minute. If you ever see an equilateral triangle where all three sides are the same, or all three sides are the same, or all three angles are the same, it works vice versa in both cases there as well. So if I see that, this case here, all three angles have to equal 60 degrees. Last of all, if you see this one down here, any triangle that's formed, all three angles have to always add up to 180 degrees. Okay, so now you've had a chance to work through all the notes. What I'd like you to do next is take these ideas and apply them to the top of your target packet up here and complete the G number 4 problem. Good luck and hopefully this video helped.